So this video is going to talk about the difference between distance and displacement. So how do you know how far you drive to get to school every morning? Well, you have to know your starting position and your ending position, and then you would measure the distance between those two things. So if you look on the picture here, we have a couple of symbols, and you're going to see a lot of symbols in physics. We will deal with a lot of equations, and so you need to start learning what these symbols mean. So X is going to be used to represent position. So you have X naught. This is pronounced not X0, but X naught, like nothing, and XF. And both of these represent a position. The naught symbol means initial. Sometimes I'll put XI for initial, but you'll see both. So this means the initial position, and this F means final, so this is the final position. We're using an X because the movement here is horizontal. You could also see a Y, so if something were falling vertically and it's measured along the Y-axis, then you could see Y naught and YF. I normally just use X for everything, but you'll see both, and you just have to recognize that as meaning position. So to answer how far you went to school, there's actually two different ways you can answer this. You can use this answering with distance, the distance to school, or your displacement. Both of these are going to measure length, but they're going to measure it differently. Distance is going to measure the length of the path that was traveled between the initial position and the final position. So if your car had any twists and turns, if the path wasn't necessarily straight, distance would measure the entire path that you traveled. And that's actually what your odometer in your car, the thing that tells you your mileage, that's actually what it does. It's going to measure the distance you travel. Displacement is another way to answer how far something is. So if you know the initial position and the final position, the displacement is the distance between those two things, irregardless of the path that was traveled between them. So in math, you know that the shortest distance between any 2 points is a straight line. And so that's what you're looking for in displacement. It's important to note that distance is always going to be greater than or equal to displacement. Displacement can be equal, but can never be greater than distance, because displacement is a straight line, which is always the shortest path. So in this top picture, the path is a straight line. So the distance and the displacement are the same. They're equal in the top picture. But in the bottom picture, the distance is a curved path, and so that's actually going to be further than the displacement, since there's just a straight line between the house and the friend's house. If you could just drive straight, that would be a shorter path than the road that you had to take. And so the distance is longer than the displacement. So displacement is the change in position. So to calculate displacement, you subtract the initial position from the final position. If the initial position is 0, then that's going to be easy, but the initial position does not have to be 0. So the equation for calculating the change in position, or for calculating the displacement, is here. So this is delta. This triangle means change in. It's the Greek letter delta. So the change in position, this means displacement, delta x. So the displacement is equal to the final position minus the initial position, and that's your first equation. So if you were given this problem and asked to find the distance or the displacement, it is 5 kilometers from home to school. The path is a straight one. So if your parents drive you to school and then return home, what is their distance that they traveled and what is their displacement? Well, for distance, it's 5 kilometers there and 5 kilometers back, so they went 10 kilometers. For displacement, you want your initial position minus your final position. Well, their initial position was home, and their final position was also home. So if you consider home to be 0, then 0 minus 0 is 0. So they actually have no displacement. They started and ended in the same place. Distance and displacement can have the same answer. They can have the same magnitude. They can be the same number. But they don't have to be. Displacement is a specific physics term that means the change in position. So distance only considers the magnitude of how far you traveled. Magnitude is the size or amount of a measurement. So the magnitude of the trip home to school was 5 kilometers, and the magnitude of the trip from school to home was 5 kilometers. The direction doesn't matter for distance. It only considers the magnitude, the amount of the length that you traveled. And so 5 plus 5 is 10 kilometers. Displacement considers both magnitude and direction. So if you consider towards school as being positive, then your displacement of your trip towards school was a positive 5 kilometers. Your displacement on your trip back, since it's in the opposite direction, that's a negative 5 kilometer displacement. And so the displacement for the trip, if you add those two displacements together, plus 5 plus a negative 5 is 0 kilometers. So there's two different ways to calculate that displacement, and I will show you those in a different video. So you have two more terms, which is scalar and vector. So a quantity such as distance that has a magnitude but does not take into account direction is called a scalar. A quantity such as displacement that has both a magnitude and a direction is called a vector quantity. So it's completely possible, as in this example that I gave you, to have moved a scalar distance but still have no vector displacement. Distance and displacement are not the same thing.